Hi everyone. So today we'll be solving the question from Striver SG sheet, and it is greed unique paths. This question is one of the most asked question for from the topic TP, and the question says that there is a robot on a MN to N grid. The robot is initially located at the top left corner. You can see it's a robot here, and we have M into N grid like rows and columns. The robot is initially located at the top left corner, and that is grid 0 0. Here, of course, the starting one, this is the first row and the first column. The robot tries to move to the right left corner. Robot wants to move here, right? This is right side and left bottom right corner, right? It wants to move to the bottom right corner. So this is completely bottom and right corner. It wants to come here, which is n minus 1 n minus 1, the last row and the column. The robot can only move either down or right at any point. The robot can only move right, that is like this, that is coming one further one column more, and at the same time it can only move up, sorry, down. It can move with a down, of course, to it have to come down to come here. It can move down or right. So we are given m into n, like the row number of row we have and the number of columns we have. We can see we have 3 rows here, and we have definitely 7 columns here. We have to return the maximum possible unique paths the robot can make. There are like so many paths definitely can have, like here there's so many, if you can see. And the test case, okay, it should be less than equal to 2 into 10 to the power 9. So you can, whenever in a question it will, it will say find all the number of possible unique paths, then we can solve that question by using recursion. That's the first thing when it should come to our mind, that should come to our mind. And again, it's a grid also, mean to end. So so many number of possible paths, these so many, right? So we are gonna solve this question by recursion. If you don't know by chance what is recursion, I'll show you. So this Google, this every time we will click here, it will come to recursion only. This is one of the best feature of recursion, Google, when you search recursion, because recursion is coming back to the same thing again. Like you will call something, but again you will finally call that thing only. Like, see, this is actually recursion. Like you are going, you went in here again, your function call will happen, and then we'll come back to 5 again here, through many ways. That is was recursion. It's like 5 first 2, then 4 also having 2, 3 is opening. So you will like, this will be like going again. When we'll go back from 0 to 5, that is when we do the recursion call, right? So as I told you, that it says the maximum number of possible unique paths. So you will be solving this using recursion at first. Then I'll tell you the different solution. Of course, it's a DP question. So the recursion code is here. If I is equals to 0, it will be return 1. Why it should be return 1, I will show you. Suppose here, at first I have taken a, okay, so what will happen at first, everything will be 0, okay. These also 0 0, right? So what is it if I is equals to 0? If this is the first row, this is what I is equals to 0 means. So to move from I is equals to 0 to here, you can only go right side only, na? You can't to move from here to here, right? To move from here to here, you just can, if you want to move from here to here, you just have one way. You can't go down and then come again right again. Then you can just take a right shift. That's you can, but that is not only, there is only one way. Just take, there is only one way. But in the question we have two ways, like we can also move right, as well as we can also move down, and as well as also right. But if you are in this, I'm just, clearing the base case so that you can understand it more clearly. So if your I is in the 0, that is you are in the first row. So to move from first row to again to this column, you just have only one way, that is moving right side. Similarly, for this column, this zeros, three zeros, these three vertical zeros, you can only move down. That's why I've written one, only one way. That is why I have said return one. That is only one way. This is nothing that return true or false. Don't think this as true or false. This is only one way when we are standing in the first column or the first row. And if any time I is less than 0, or if it's negative, then of course it's out of bounds. This is simple thing recursion of simple thing of recursion, best cases. And again, if it's a recursive call, of course, to move up and left, because see, I've told you, you're just going. Again, you will move. You have First, you have to find the paths in recursion. You have opened all the paths. Now, again, you will come back. That is the beauty of recursion. First, you open the paths, then you come back to your beginning of the path. Right? You come back to your starting point. So now, see, you went down, then right. But again, you will come to here. So now it will be up and left. So if you are moving, first remember, first you went down, but now you will come back. That is what we will return now, because that finally we are doing the recursion call. So now you are moving up, but for that you have already done the down and the moving right. So now we are moving up. Okay, so for moving up, if you want to move up, I'll show, sorry, not this, my bad. If you want to move up, what column is changing, right? Column is changing. You're just moving from here to here. Column is changing? No. Same, we are in the same column, right? We are in the same column. So row number is changing. Therefore, I've written I minus 1 and j. Column will be same. Now you are taking left. So for left, you're in the same row. You're in the same row. You can take left from here to here, right? You can take left from here to here in this. So you are moving actually in the same row. So row will be I, and then but you are moving one row back. Therefore, j minus 1. Sorry, one column back. You are changing the column. Therefore, j minus 1. And finally, returning the m minus 1 n. Because this is the final place where our solution will be present. Because it's already given. We have to find the solution here. You have to come here. Number of possible ways the robot can come here, that is n minus 1 and m minus 1. Therefore, returning that. And of course, 2 into m plus n. There are so many, ways. So many, like m, n. Therefore, the time complexity is 2 to the power m plus n. And of course, the space complexity will be m plus n. Because of the grid, m plus n space is here, no? That's why. And now if you see the memoization code, which is top-down DP, okay, this was recursion. This is actually similar to recursion, but one catch point here is that we don't have to, only this is the catch point. Everything is same. We are making a DP table, okay, that is the main task. And now we have this, if DP is equals to this one. If DP, at first see, you can take that is a 0 also. Suppose think 0 as minus 1. So, okay, I'm writing let 0 is equals to minus 1. Just think that way. So, all are minus 1 here. Okay, now after that, you are just calculating. Minus 1, minus 1, like this. Okay. So what it said, at any point, and now if suppose these are already calculated, okay, this recursion is doing the same thing again and again. right? Recursion is doing the same. So these are already calculated. So dp of I is not is the -1. So we don't have to calculate it once again. In recursion, it was calculating multiple times. That is why 2 into m plus 1 was the time complexity. But in memorization, this line is the main catch, you know, main catch point, where we have just use if dp of I is not equals to -1, then please return that dp. If it is -1, then please calculate for that particular grid also, that is dp of ij, which will finally give us, holding the value for each recursion call. And finally I'm returning n-1 dp, which is having the result. That's it. This is the catch point for the memorization. And of course it was exponential, right? 2 into m. You can see every time recursion is having two left and right root, so tree type of structure, right? Recursion m, that is why 2 to the power m plus 1. And of course here no such things are here. It is just m into n. That is the great thing, because we have this catch point here. Therefore the time complexity will be big of n to n, and because of the dp array, m into n also big of n plus 1 for the recursion stack. And for the tabulation, this is one of the best, not the best, it is also similar to kind of a little have a much better space complexity. That is the tabulation form. Okay, so these are the best case. I have already make you understood, right? If it is the first row, then of course one way. I've already told in the beginning, if you are in the first row, there is only one way to move right, or if you are in the first column, then only one way to move down. These are the best case. I have make a dp table. And yeah, finally this dp of ij is storing, this is actually bottom to top approach. This is storing the final dp of I is storing the recursion call, like the tabulation form answer. That is, I have already explained what is I-1 in the previous part of the video. And finally returning dp of n-1, that is where our result is present. And time complexity is big of n2, because we do not have a recursion. This is not a recursion thing. That is why recursion stack space is not used here. So little more space complexity is reduced. This is one of the, this is actually the best, like, this is space optimized because it's a grid. So already time is already, it's already reduced. Now we have to check on the space. So I have taken only one. Okay, so actually maximum time in interview, if you just tell recursion, memorization and tabulation, it works. Okay, but also best to say this also, then you can say 101% your interview will be cleared, until and unless your interviewer is not that crazy, so basically this vector will store the previous row and this will store the current. So I'm first in this and again here. So basically in every iteration it will, because see, this was the prev row, this is the current, this is already having a this will store this answer, and this is the current, right? So this can take the value from here also, right? And again prev is equals to new update will happen, right? That's how this actually works. I know I'm not able to make you understand because I don't have writing pad, I know that kind of sucks, but I wish I had one and could have make you understand in a best possible way. But anyway, okay, so this you can check from Shriver's SD sheet. But if I just make you understand, when we are calculating here, we are in this row, we are already calculating. So previous vector is storing that. Now again we are here. Okay, so current is taking this vector storage right now currently. Then current is calculating all of this, right? And previous be like, okay, then this will be the new previous and this will be the new count, right? That is what is happening. So it's efficiently storing the reducing the space, okay, by shifting between previous and current. That's what, just for the space optimization tabulation. But it's okay if you don't understand this, but Better to check it once from Shriver video or Priyansh Bhaiya's video. I hope. And yeah, again, the space complexity is reduced because only one row is stored at a time, right? Only you are taking your talk, you are solving this, and then again, this becomes your new brave, like that. So I hope I could have make you understand the basic first question of DP. And if you read, please keep lead coding. Bye.